Okay, so it says this. Dennis and Nancy Wood are celebrating their 30th wedding anniversary by having a reception at Tiffany Oaks Reception Hall. All right, so they only budgeted $3,000, not $3,001, $3,000. That was the max. So they only budgeted $3,000 for their reception. The reception hall charges $50 cleanup fee, and then for each person they invite, it's $34 a person. And the question is, find the greatest number of people that they may invite and still stay within their budget. All right, so find the greatest number of people that they may invite and still stay within their budget. Okay, so let's go ahead and represent the unknown. All right, so you're going to say I'm going to let x equal. Now, what is it you're trying to find?
The number of people.
Okay, the number of people they can invite, right? All right. Now we got to set up an inequality. This is going to be an inequality, not an equation. So when on your test 3, when you set this thing up, it's got to be an inequality. It cannot be an equation because it says this. What's the greatest number of people? So that means that your inequality is going to be a less than or equal to. So you're going to set up your inequality. All right, now you do it just like I did the equation part, like 9.4. All right, so if you recall 9.4, when you read this, it says that the reception hall charges $50, right? Is that a one-time fee or is that $50 per person? One-time fee. All right. And then it's $34 per person. So how do you represent that part, do you think?
34x plus 50.
34x plus 50 or 50 plus 34x. Okay? So 34x plus 50. Okay, now, what's the maximum they can budget? 3,000. So what they spend here, the maximum has to be what amount? 3,000. So when I say the maximum has to be 3,000, that means that the money I spend can be less than or equal to what? 3,000. So that's your inequality. The maximum you spend has to be 3,000, which means that the amount you spend has to be less than or equal to 3,000. You cannot go over 3,000. That's all the money you have. All right, and then you're going to solve this inequality. So what's the next step? Subtract 50. And so you get 34x is less than or equal to, well, that's going to be 2,950. All right, so then you can divide both sides by 34. So when you divide by 34, you're going to get, you're going to get this. You're going to get that x is less than or equal to, so 2,950 divided by 34. So it's like 86, and I'm going to go ahead and write this as a mixed number. You get this decimal, right? 86, but let me just go ahead and write this as a mixed number. So remember how you use your calculator to do that? So you say second, PRB equal, and so it's like 86 13/17. Is that what you got in your calculator? Make sure you got that. 36 13/17. Okay, now let's go. I'm going to go ahead and look at it in decimal again. Now you got to be careful because we are talking about the number of people, right? So don't say X is or the maximum person has to be 86.76. So you can't have part of a person. So this number has to be a whole number. So he said, would you round it? Well, it depends on the context of the problem. So if in a previous course, if you're asked to round this number, look at the display. If you're asked to round this number, what would you round it to? Yeah, because this right here is, remember the tens place, if that's 5 or bigger, you add 1. So you would say 87, right?
No,
Why not?
because that was what you over your 3,000.
Exactly. So you got to be careful when you say do you round? Because if you say 87, so either the answer is 86 or what? 87, right? Okay, but before we discuss this, let's go back over here. So what I found is this. I found that the number of people I can invite and still be within my budget has to be at most what? 86 and 13/17. Okay? So if I invite 80 people, can I invite 80 people?
Yes.
Yes. Will I be within my budget?
Yes.
Yeah, I mean you can check it. 34 times 80, 34 times 80 plus 50 equal 2,000. You can't see it, but 2,770. That's less than 3,000, so I'm within my budget. Can I invite 2 people if I wanted to? Yeah. Can I invite 86 people if I wanted to? Did anyone say no? Why'd you say no? Can I invite 86 people?
Yes.
Yes, you can. Because I can invite any number of people that's less than or equal to what? 86 and 12 and 13/17. 86 is less than that number, right? And you can check it. 34 times 86 plus 50 equal 2,974. That's less than 3,000. But here's where people mess up. So they look at this decimal right here. I'm going to go ahead and do it again. What was that? All right, they look at this decimal and they think, well, I'm going to round this thing off. And so they're going to say 87. Well, if you check 87, you get 34 times 87 plus 50. Are you still within your budget?
No.
No. You're over your budget. Now, $8, you can borrow that from a friend, but that's not what the problem's saying. You only have at most 3,000. So if you look at this, though, you know that 87 is not less than or equal to this, correct? So the maximum number, now you got to answer the question. So the maximum number of people I can invite is what? 86. That's the maximum. That's the greatest number of people I can invite is 86. So be careful when you do some of these application problems. Make sure you read the context of the problem. All right. Let's look at, let's look at 87. Okay, 87, you're told that Eric Daly has scores of 75, 83, and 85 on his history test. So there's only 3 tests in the course, and then the final. So use an inequality to find the scores he can make on his final exam to receive a B. The final exam counts as 2 tests, and a B is greater than or equal to 80. A B is greater than or equal to 80. All right, so you're going to represent the unknown. So you can let x equal, and you're trying to find, what are you trying to find here?
Grade on the final exam.
The grade in the final exam, so the score in the final exam. All right, now let's set up the inequality. All right, so there are 3 test scores and then a final, correct? All right. So you want the average to be what grade?
80.
A B, an 8, at least an 80, correct? How do you find the average?
I am not together.
Add them up and divide by however many you have, correct? Y'all agree?
Yes.
Okay. All right, so my inequality, let's look at the test scores. What are my test scores? 75, I'm going to add those up. 75 plus what? 83 plus 85 plus, and then the final exam, which counts as how many tests? 2. So if you want to, you can say x plus what?
2x.
Or you can say 2x, x plus x or 2x. You see what I did? All divided by what? Not 3, 5. How many test scores are there altogether? How many scores are there altogether? There are 5. There's a 3 tests and then a final, because the final counts how many times? 2 times. So I must divide by what? 5. And that average must be bigger than or equal to what? 80. So there's your inequality. So that's going to be your inequality. So there are 5 scores altogether, the 3 tests and the final that counts as 2. And remember, to find the average, you add them up and divide by the total number you have. Now, the reason you can do it this way is because all of the scores have the same weight. All the scores have the same weight. All right. Now, when you do, at the end of the semester, when you do yours, it's not the same. You don't do it the same way here because all the categories don't have the same weight. Understand? Like if you go to worksheets, what percentage is your worksheets? 13 or 12%. The My Math Lab is maybe 1% less or 1% more. The test is 50%. The final exam is 25%. So you can't do it that way for yours because they're not all weighted the same. But in this example, this is a simple example because they're all weighted the same. All right, so that's where we're at. Now, what's the next thing you're going to do?
Multiply by 5.
All right, so you're going to use the idea that LCD. So you can clear your fraction. So I'm going to multiply both sides by 5. So let me go ahead and rewrite this over. Okay, so times 5, what you do one side, you do to the other. Okay, these 5s divide out, correct? So combine like terms, what's 75 plus 83 plus 85? 243, so I get 2x plus 243 is greater than or equal to, and then was that 400? All right, then do what? Okay. And so I get 2x is greater than or equal to,
157.
all right. Then divide both sides by 2. So x must be bigger than or equal to what?
157.
157 divided by 2, which is what? 78.5? All right, 78.5.
So you actually do want this one.
Well, okay, so in the previous problem, I said don't write as a decimal, right? And the reason because that decimal did not terminate. So if you go back, right, and that's another point. That's a good point to make. So on a test, I mean, on your worksheet, some of you get 0.5s all the time, right? Yeah. 0.3s, 0.2s. So you can have on a test a decimal. But going back here, I told you not to write as a decimal for one reason, that decimal didn't terminate. So if you go back and you do this again, how would you write this? How would you write it? You're not gonna round this because it's no longer exact. You round it off. So that's why here I told you not to write as a decimal. I told you to leave it as a mixed number. Okay? Here it's okay to round it as a decimal for one reason, because it terminated. What was that last digit? a 5. It terminated. Okay? So that's the main reason. All right. Now, let's answer the question. So the question was this. What must a student make on that final exam to get a course grade that's 80 or bigger?
Nothing less than 78.5.
He must make at least a 78.5 on the final. So the student must make at least 78.5 on the final exam. Okay, let's look at 68. 68. All right, so a 170-pound person uses 5.3 calories per minute when bicycling at a speed of 5.5 miles per hour. How long must a person ride a bike at this speed in order to use at least 200 calories? And then it says round up to the nearest minute. So round up the nearest minute, it says. Okay. All right. So again, you have this 170-pound person. The 170 may or may not be using the problem. We're going to determine that. But we do know that for every minute you're on that bicycle, you use up how many calories? 5.3. As long as your speed is what? 5.5 miles per hour. All right, the question is, how long must a person ride a bike at this speed in order to use at least 200 calories? Okay? All right. So let's go ahead and represent the unknown. So we're going to let x equal, no, not the speed. It says how long, right?
Yeah.
So the number of minutes on the bike. Number of minutes on bike. So the number of minutes you have to keep bicycling to use up at least 200 calories. Okay? All right, so how long must a person ride a bike at this speed in order to use up at least 200 calories? All right. So you see the part that says the 5.3 calories per minute? All right. So how would you represent that expression?
5.3x.
5.3x. So for every minute you're bicycling, you're going to lose or use up 5.3 calories, correct?
Mm-hmm.
So if I am on the bike 5 minutes, I mean, when you go to the gym, you do that treadmill, it tells you, one function could tell you how many calories per minute you're using. So you would just say 5.3 times what? If about times 5 is what I said, right? 5 minutes. All right. But in this case, we don't know how many minutes. You can let that be what? X. So 5.3x. All right. Now, am I going to use that 170 anywhere in that problem?
No.
No. Am I going to use that 5.5 anywhere in that problem?
Yes.
Where? I mean, okay, you got to think about your own experience. Okay, so you're on a bike, you're riding this bike, okay, and you want to you're consuming, or not consuming, but you're using up 5.3 calories for each minute. Okay? Is that enough to tell you how many calories you're burning off? Why not?
Yeah, because it tell you 5.3 calories.
Yeah, it is enough. This right here is enough to tell you how many calories you're burning off. If I'm on this bike for 10 minutes, how many calories did I burn off? 53 calories, right? What was that? Say it again?
You gotta maintain that same speed.
Right. I mean, yeah. In some of these word problems, you're assuming you're maintaining the same speed. Yeah, obviously, that is a true statement. So that's enough to determine how many minutes you need to burn off. So see that 5.3. So your question is, well, why is that miles per hour in there?
Yeah.
Well, that's where that 5.3 comes in. So they're telling you that if you're on this bike and you're traveling at, what was it? 5.5 miles per hour, you're going to burn off how many calories per minute? 5.3.
So you don't have to use a 5.
No, not at all. You don't have to use you're not going to use a 5.5. That 5.5 miles per hour tells you how many calories you're going to burn a minute. So if you go and you Google, obviously you can find this information. If you Google how many calories you burn off per minute going 20 miles per hour, there's a table probably that's going to tell you that. So there's this table that tells you if you're traveling at a constant speed of 5.5 miles per hour, you're going to burn off what? 5.3. Now you also have that incline, correct? So you always have all like hills and things like that, but we're assuming it's a level ground here. That's enough. So if they had said that this person's traveling 10 miles per hour, would this still be 5.3 calories per minute? You said yes or no?
Yes. Yeah, it would, because you're going to stay the same. The calories per minute.
Okay, I'm gonna say this again, okay? You gotta think about your own experiences, people. Listen to me, listen to the words I'm saying. If I'm traveling on this bike at 5.5 miles per hour, how many calories am I burning off? 5.3 each minute. Okay? I have a friend who's going 10 miles per hour. Is he going to burn off the same number of calories? No, he's going to burn off how many? Well, not how many, but he's going faster. So he's going to burn off more calories, right? You're not even thinking about your own experiences. You dealt with this since you can remember. Just think about it, about being in the gym. You're doing something very light, and then the next person next to you is like going crazy. You're telling me you're burning off the same number of calories? No. So I'm going to ask this question again. If the problem had stated you're traveling 10 miles per hour, would this be the same number of calories you burn per minute? No. So that 5.3 has to do with the fact that you're traveling how many miles per hour? 5.5. That is all you need to set up the inequality. You just have to know now that the number of calories you burn has to be at least what? Listen to the words, okay? You're not listening to what I'm saying. The number of calories you burn has to be at least what amount? 200. Okay, I want you to use the word 200. Now, what inequality implies at least? Greater than or equal to. At least means if I say I'm at least 30 years old, that means I'm 30 or what? Older. So you're not going to say less than or equal to. You're going to say what? Greater than or equal to. So this means at least. So at least means bigger than or equal to. And it has to be at least what? 200? So that's your inequality. So the one, And the 170 also has to do with the fact that your weight and your speed has to deal with how many calories you burn a minute. So a person that's very thin probably is not going to burn off that many calories a minute. So your weight and your speed and the incline, that all has to do with how many calories you burn off. All right, so that's the inequality, and all you do is that one more step. What's the next step? Divide by 5.3. And so x must be bigger than or equal to, let's see, 200 divided by 5.3. All right, so you get this decimal doesn't terminate, right? So let's write this as a mixed number. See why I'm not writing as a decimal? Okay. So second PRB equal, so it's what, 37 and 39.53? So the number, and then it says this. It says, and the problem, it tells you to round up to the nearest what? Minute. Okay, so question was, how long must a person ride a bike? So how long must I ride this bike? 37 minutes or 38 minutes? 38 minutes. So I must ride this bike at least 38 minutes. 38 minutes or more, right? To burn off what? 200 calories. At least 200 calories, because it said at least 200, right? All right. So you need to ride the bike for at least 38 minutes to burn off at least 200 calories. Now, technically, any number bigger than 37 and 39.53 would work, but they tell you to round off to the nearest whole number. All right, so that one wasn't easy for you, for many of you, this particular one. So go back and look at it again. All right, so let's look at 66. All right, so a surprise retirement party is being planned for this person. So it's kind of like 65, I guess. So it says that a total of $860 has been collected, and the reception hall charges a cleanup fee of $40 and $15 per person. And then find the greatest number of people that may be invited and still stay within the budget. So it's the same problem. So what would you let X be? Number of people. Okay, so number of people to invite. All right, so you're going to set the inequality. All right, so how would you set this up? Start with that. Say it again.
I'm gonna say 40 plus 15 is less than or equal to 860.
Okay, so 40 plus 15x, so that's going to be the amount you're going to spend, right? You all agree? All right, and the maximum you can spend is how much? 860. So remember I said the maximum you can spend is 860. So that means that you can spend 860 or less. So that means less than or equal to 860. All right. So you got to be careful. Sometimes when people think max, they want to say greater than or equal to. But that's the maximum you can spend. So that means you can spend $860 or less. So that's what this means. Okay, so subtract 40. You get 15x is less than or equal to 820. Divide both sides by 15. X is less than or equal to
54
Yeah, so you get this this decimal, correct? So as a mixed number, and if you did not know that points, what's 0.6666?
Like 12.
2/3. So if you did not know that, just use your calculator, and you get 2/3. See the 2/3? So 54 and 2/3. All right, now remember what that says. That says I can invite any number of people that's less than or equal to 54 and 2/3, correct? All right, so the question is, what's the maximum number you can invite, though? 54. Because 55 is not less than this. So don't round off, even though in a previous course, when you're told to round this number off, if the tens place is 5 or bigger, you would say this is 55. So you got to be careful. You're not going to say 55 here, because 55 will make the amount you spend bigger than 860. You can only go up to 860. So the maximum number of people I can invite is 54. That's the maximum. Okay? All right. Okay, so that's going to take care of the word problems from this. So I'm going to assign this section probably tomorrow morning. But before we do that, let's go back and review something like this. So let's say you want to solve -2 times x minus 3 plus 5 is less than or equal to 3x minus, in parentheses, let's make that 4x. 4x minus x plus 2. All right. So in your test, how would you do this problem? Distribute. Okay. So the left side's easy. So I get -2x and then what? Plus 6 plus 5 less than or equal to. Now, what do I do on this side? Distribute the -1. Okay, good. So that's 4x, and then what would I write? Minus x minus 2. All right. Then what's the next step? Combine like terms. So that's going to be -2x plus 11 is less than or equal to 3x minus 2. Okay, what's the next step? Well, we already combined like terms, so there's nothing else to combine. Okay, so you want to bring the variables to the left, constants to the right? Okay, so I'm going to subtract 11. So I get -2x is less than or equal to 3x minus what? 13. What's the next step? Okay. Then combine like terms. What's a -2x and a -3x? It's less than or equal to. Okay. What's the next step? Okay. So. Okay. All right. So whenever you multiply, divide by an inequality, you got to remember to reverse this inequality symbol. So x is going to be what? Greater than or equal to. Now, remember, you got to remember that a negative divided by negative is going to be a positive. So you're going to say 13/5, right? So your solutions would be any number that's bigger than or equal to 13/5. Now, here's the question. So if I have a number line, and let's say this is 0, this is 1, this is 2, this is 3, and so on, where would you put 13/5? Okay, why would you say anywhere between the 2 and the 3?
Because the mixed number is 2 and 3/5.
Okay, so the reason is because if you put 13/5 in your calculator, what is that? 2.6. Okay, so 2.6. So when you place 13/5 on the number line, it's got to be, now she said be anywhere between 2 and 3. Well, be a little bit careful, because if you make it close to 2, you're going to be very upset. Because it is not close to 2, it's actually closer to what? 3. So just do somewhere around here. So this right here would be 13 fifths, right? Okay, so 13 fifths. All right, now, let's talk about open or closed circles. Is this open or closed? Closed. Going which way? To the right. So there's your graph. So that's a graph. Any question before we go on with this? Okay, now, what would the interval notation look like?
It's gonna be
Bracket. Because of the closed circle. 13 fifths, comma, infinity parentheses. All right. And then on My Math Lab, and on one of the worksheets, they talk about set notation. How would you write this in set notation? You remember those braces. Remember the braces. So you can say set of x such that x is greater than or equal to 13 fifths. All right. Okay. So on the test, probably those are going to be integers, but just in case for some reason there's a fraction, use your calculator to approximate this fraction and then put the fraction on the number line where it should be. All right. Okay. So this is going to be worksheet. All right, you have these two inequalities, x is greater than 2 and x is less than 6. Now, what word is joining those two inequalities? Okay, and. Now, what I'm asking is this. I want to find all of the solutions that are greater than 2, and at the same time, they have to be what? Less than 6. That's what this is saying. So it's not just saying find all the solutions bigger than 2. It is saying find all the numbers that are bigger than 2, and those numbers have to be what? Less than 6. So give me a number that you think may work here. 4. Okay. Is 4 bigger than 2? Yes. Is 4 less than 6?
Yes.
Yes. Give me another number. Okay. Now you'll keep choosing integers, or whole numbers, but you could say 3.6 as well, couldn't you? Okay. What would not work? 7. Well, why would 7 not work? Because 7 is bigger than 2, but it's not less than 6. All right. Now here's another question. Would 2 work? No, 2 would not work either. Why? Because 2 is not bigger than 2. 2 equals 2. Would 6 work? Nope. Because although 6 is bigger than 2, 6 is not less than 6. 6 equals 6. So in terms, now here's how you're actually going to do this. So as we go through these inequalities with this word and there's also going to be the word or. We're going to talk about or in a little while, but for right now we're just focusing on the word and. So you're going to graph each one individually. You're going to graph each one individually, and the way you want to do this, and how many inequalities do you see here? 2. So you're going to put 2 number lines. You're going to put 2 number lines, and you're going to line those numbers. So in other words, if this is 0 right here, I'm going to put 0 right here, right under each other. You want to line them because that's going to be necessary. If this is 6, then this right here has to be what? 6. If this is 2, then this right here, I'm sorry, -2, this right here has to be what? -2, and so on. Okay? All right, let's do the first one. So let's graph all the numbers that are bigger than 2. So where do I put the number 2? On the right of 0, correct? So let's say 2 is here. I'm going to put 2 right here as well. Open or close circle? Open. Going which way? To the right. Now, what I've graphed here, these are the solutions to which inequality? That first one. Okay, now let's do the second one on that second graph. So on 6, do I use open or close circle? Open, because there's no equal sign, going which way? To the left. And remember, we said that the solution, we were talking about this earlier, we said that the solution would be any number that's bigger than 2 or less than what? And less than what? 6. So if you look at the two graphs, you see where these things overlap? They overlap between what? Two numbers? 2 and 6. That's where they overlap. So when you talk about the AND statement, you're looking for where they intersect. So the AND statement is the intersection of the two graphs. So you graph each one individually, and then you see where they intersect. So whether those two graphs intersect? Between 0 and 6. So then you're going to do a final graph. So your answer, you can do the graph again. So here's 0. Now I'm going to shade in, remember I'm shading in every number between what two numbers? 2 and 6. So here's 2, here's 6. And then on 2, do I use open or closed circle? Open. On 6, open or closed? Open. And where do I shade? In between. So there's your graph. Okay? So when we do this, now listen, when we do this, you're going to graph each one individually. Then you're going to use the fact that this is an AND statement, so you're going to look to see where they intersect, and then you're going to tell me your final graph. This is your final graph right here. All right, so an AND statement is an intersection. An AND statement is an intersection. All right? Now, let's look at an OR statement. An OR statement. So for the OR statement, let's look at this. Let's say I had x is greater than 4 or x is less than 3. X is greater than 4 or x is less than 3. So an OR statement. So you can see the difference between an AND statement and an OR statement. Okay. So if I graph the first one, x is greater than 4. So let's say this is 0 and let's say this is 4. On 4, do I put open or closed circle? Open, going which way? To the right. Okay? Now let's do the second one. Here's 0, and then 3 is around here, let's say, right? Make sure when you do this, you're aligning the two graphs. So don't put 3 on this side of 4, because it's no longer aligned, so you're going to mess up. Make sure it's aligned correctly. So this is where 3 should be. Open or closed circle? Open, going which way? To the left. All right, now let's talk about what we just did. Okay, so what eventually I'm trying to do is this. I'm trying to find the solutions to this statement. Now, when you have two inequalities, 2 or more inequalities joined by the word and or are, these are called compound inequalities. So we're dealing with compound inequalities. So a compound inequality is where you have 2 or more inequalities joined by either the word and or the word are. So I'm trying to solve this compound inequality. So listen carefully. This says this now. I want to find all of the numbers, all of the solutions, such that x is bigger than 4 or x can be what? Less than 3. Okay? So we graph each one individually, and then the question becomes to you. What can be your solutions?
Negative
Okay, so what would not be a solution? What number would not work? Give me a decimal.
3.8.
3 point what? 3.6 would not work. Now here's why 3.6 would not work. You're going to say, well, first of all, is 3.6 less than 3? No. So right away it's not going to work, correct? Okay. 3.9 is not going to work because 3.9 is not less than 3, nor is 3.9 what? Greater than 4. But why does 5 work? But 5 is not less than 3.
Yeah, but it's or.
It's an OR statement. So an OR means this. Your number has to satisfy one of them. At least one of them. It doesn't have to satisfy both. It has to satisfy at least one of them. So an OR means union. So an OR, all you have to do with an OR statement is satisfy one of them. An AND statement, you have to satisfy both. So AND means intersection. It has to satisfy both. OR, it's got to just be one of them. So when you think about the word OR, you're going to think union, meaning this. Anything that's shaded is a solution. Anything shaded is a solution. So if you look at the two graphs, everything is shaded except between what two numbers? 3 and 4. So look, this is what I'm going to do. I'm going to go ahead and you see how I did this right here where I kind of drew those vertical lines between the two graphs? Let's do the same thing. So anything shaded is a what? Solution. Do I shade between 3 and 4? No, because there's nothing shaded there. But I am going to shade between what? 4 and infinity. Okay, so any of those numbers here works. So your graph, your final graph, you're going to say from negative infinity to what number? 3, with an open or closed circle. Open, don't forget the arrow right here. And then you're going to say from where? 4, open or closed, going which way? To the right. So there's your graph. Okay. All right, now, remember, in our statement, anything that's shaded is a solution. Anything that's shaded is a solution because it satisfies at least one of them. Doesn't have to satisfy both. It's got to satisfy at least one. And it's got to satisfy both. So that's why you look for the intersection. An and statement, you look for the intersection. All right, let's talk about the inequality, how you would write this as inequality. Let's go back to this one right here. How would you write this as inequality? That was one of the worksheets you had to turn in. How would you write this? Parentheses, 2, comma, 6 with parentheses. Okay, that would be the inequality. All right, now for this one, remember this is your final graph right here, so this would be your answer. For this one, if I cover this up, how would you write this as an inequality? Infinity to 3 with parentheses. Okay, now you see the word R, and you see how these two parts of the graph are disjointed? So you can use the word union, U for union. This means union. So from negative infinity to 3, union, what other inequality? 4 to infinity. All right, so that's how you write it. So negative infinity to 3, union 4 to infinity. All right, so and is the intersection, R is the union. But notice when we did this, we graphed each one individually. And then we looked for the intersection. And then we came up with the final graph. Same thing here. You graph each one individually. Then we looked for anything that's shaded. Anything shaded is a solution. And then we come up with the graph. And then we have our inequalities. All right, now let's look at this one. Suppose we had this. So listen carefully. Let's solve. X is greater than 3 and X is greater than 6. X is greater than 3 and X is greater than 6. All right, what would you do first? Graph each one separately, okay? So let's graph the first one. So here's 0, here's 3. So on 3, what do I put? Going which way? To the right. Okay. Now remember, what I graphed were only the solutions to which inequality? The first one. Okay? Now let's do the second one. So here's the second one. Always align your zeros. Always align the zeros. Otherwise, if it's misaligned, you're probably going to mess up with your final graph. Okay, now where do I put 6 on this number line? Can I put 6 right here? That's it. I'm asking this question. Now tell me yes or no. No, I cannot. Don't put 6 right here. Make sure it's aligned with the other one. So can I put 6 here?
Yes.
Okay, good. Open or closed?
Open.
Going which way?
Right.
All right. So what I've graphed here were only the solutions to this other one. Now let's talk about, okay, then what's the solution to this compound inequality? 3 to infinity? 3 to 6?
It's 3 to infinity, so they all are going.
Okay, so I'm going to ask you this. Is 4 a solution?
Yes.
Why is 4,
Greater than 3.
but is it greater than 6?
Oh, no.
No, 4 is not a solution. So do you still think the answer is from 3 to infinity?
No.
Mm-mm. Don't make it difficult. When you see the word and, what do you look for? Where they intersect. Where do those two graphs intersect? From 6 to what? Infinity. That's where they intersect. Okay, so your answer, your graph, here's 0, here's 6, open or close circle. Open. Going which way? To the right. So there's your graph. So only those numbers that are shaded is a solution to this compound inequality. And you can check. Let's check 7. Is 7 bigger than 3? Yes. And is it also bigger than 6? Yes. Do y'all see why 6 is not a solution? 6 is bigger than 3, but what's the issue? 6 is not bigger than itself. It's equal to itself. Okay? All right, and then what would be the interval notation? Yep. All right. Okay, let's look at this one. Suppose I had this time. X is bigger than 3 or X is greater than 6. X is bigger than 3 or X is greater than 6. So same inequalities, except this time I'm using what word? Or. So again, you still graph each one individually. All right? Make sure you do that. Make sure you graph each one individually. So if I graph the first one, here's 0, here's 3. Open a closed circle. Going which way? To the right. Here's the other one. So here's 0. 6 is here. Open or closed? Going which way? To the right. Okay. Now, here's a question. What's the solution to this compound inequality?
4, 5.
4 and 5, that's all it is? Okay, someone said 3 to infinity. Remember in the previous problem, someone said 3 to infinity and then realized it didn't work? Does 3 to infinity work here? You got to remember with the word or, what do you look for? Or anything that is what? Shaded. Anything that is shaded. Is this shaded right here? Yes. Anything that is what? Shaded. Okay? Anything that is shaded. So 4 is a solution because 4 is bigger than 3. You may say, but 4 is not bigger than 6. It's okay because this is an OR statement. It's got to satisfy one of them. So an OR statement, you can look for everything that is shaded. Everything that is shaded. So what would your final graph look like? Here's 0. What do I put? 3. Open or closed? Going which way? To the right. So that will be your graph. Any number that's from 3 to infinity, not including 3, but 3 to infinity is a solution. Make sure if you think it's something else, make sure you understand why your idea doesn't work. Because that's going to be important. One word's and, the other one's are. What would the inequality be? With parentheses, infinity, parentheses. Okay? All right, let's look at this one. All right, so x is greater than or equal to -2, and x is less than 6. X is greater than or equal to -2, and x is less than 6. What do I graph first? Okay, remember this is an and statement, right? Make sure you look at your word. So here's 0, here's -2. Open or close a -2? Going which way? To the right. Okay. Let's do this, the other one. So here's 0, here's 6. Open or closed?
Open.
Going which way? To the left. So what do you graph? Oh, I'm sorry. What's the solution do you think going to be?
Anything between -2 and 6.
Any number between...
-2 and infinity.
No, you had it right the first time. Because remember, it's anything that is what? Shaded.
Yeah.
I'm sorry. No, anything to have in common. Because this is an and statement, right? So you're looking for intersection. Intersection. So what do they intersect? They intersect between -2 and what? 6. That's where they intersect. So remember, and means intersection. Intersection. So your answer, then, you're going to put what number first? Open or closed? Okay, if you can use brackets or parentheses, it'll be bracket. If you use open or closed circle, it would have to be what? Closed. All the way to what? 6, open or closed? Open. And shade in everything between. Okay? Now, if you had used parentheses and brackets, you would have had to say this. -2, 6, bracket on -2, parentheses on 6, and shade in between. What would the interval notation be? 2, 6, parentheses. All right. All right, let's do, now listen carefully to this one. Let's do one more. Same 2, except we're going to use the word or. I just want to see if you think you know what to do. Okay, same 2 inequalities, except this time we're using the word or. So you graph each one individually. So here's the first one. -2, open or closed? Going to the right. Here's the other one. 6 is here, open or closed? Going to the, not the right, but the left. All right, remember, this is an or statement, right? Or means union. Or means anything that is shaded. Anything that is shaded. So what do you think the answer is? Negative between -2 and 6? So you're telling me that that 15 would not be a solution?
Oh, it's, negative infinity and positive infinity.
Okay. Remember what she said at first. So then I asked, I said, so you're telling me that 15 would not be a solution? Well, let's check. Is 15 bigger than or equal to negative 2? Yeah, so it's a solution. You didn't even have to do the other one because it doesn't work here, but it doesn't matter as long as it satisfies one of them. But then she changed her tune and said from where? Negative infinity to infinity, because what is shaded?
Everything.
Everything is shaded. Remember the arrows? Keeps on going, right? Everything is shaded. So your graph, so this is what you do in your graph. You just shade everything in the graph like this. That's what you do. That's how you would graph it. And there was the interval notation though.
Negative infinity.
Parentheses, negative infinity to infinity with parentheses. Okay? All right, so we'll work on this some more next class period. But I do need for you to go back and review this before next class period. Okay? All right, it's not that difficult. You just got to go back and remember the word and means intersection. The word or means union. Okay? That's what you got to remember about those two words.